Right, afternoon everyone. My name's Hansen. I'm from Aspera, and I'll go to the next slide. Let's see, here we go. Right, okay. So over the past 5 years or so, I've actually been intimately involved in helping our customers move what we now call big data. Aspera has its origins when Aspera started in 2004 from primarily the broadcast industry. They were actually the first ones who had what we would now call big data. And there was a need to efficiently move large files and large file sets over large distances. That's how it all started. So, Aspera we provide software that runs on commodity hardware, both on-premise and also in the cloud, that allows you to move any kind of digital assets at maximum speed over any kind of network. Of course, in the last few years or so, we've seen a big uptake in using cloud-based services. So the way we see it is that if you do have a big data that you need to both transport and process in some way, using the cloud is very compelling. One, because it's there's the potential of infinite computing resources. So there's no need to plan ahead. It's there. It's elastic. You can turn it on by the flick of a button. And of course, also turn it off by a flick of a button. There's no upfront commitment. So, of course, it reduces the capital outlay. And, of course, it's pay as you go. CPUs by the hour, storage by the day, etc. So that's what makes cloud so compelling. And sometimes we're asked what constitutes big data. And so the way we see it is two trends. One is, of course, that the size of the data sets are, of course, increasing, but at the same time, the size of the files that our customers need to transport are also increasing. So we have this kind of double whammy effect where you have increasingly larger data sets and need to be transported, and at the same time, the data is becoming more and more unstructured. So what we see is, for example, that within the life sciences industry is a very good example where there is, an increasing amount of hardware available that allows you to do any kind of genetic sequencing. And what do these kinds of hardware genetic sequencers have in common? Well, they all produce a vast amount of data. And the same thing goes for even portable documents. I have customers in the publishing industry, for example, who see that the size of their regular documents that they have is actually increased about 5 times in the last 2 or 3 years. And medical imaging is another example, computer modeling, etc. There are some challenges with actually transporting data, especially over large distances. And I'd like to tell you a story. So about a year ago, I was at a trade show, and a person comes up to me and says, "Yeah, I've got my lots of big data, and I normally store it in a data center, which is actually across the road." And I went, "Okay, fine, yeah, that's fine. But now I want to just get rid of that data center. I have my 1 gigabit line into that, but it's very expensive. And now I actually just want to move all my data to the cloud, and maybe also just store some of it directly on premise." So I said, "Okay, that's absolutely fine. But have you thought about how you're then going to actually transport your data in and out of the cloud? And also, if you have some data that's just sitting within your own office network, how will you get that to people who need to analyze that data? And when that's been analyzed, how will you get it back again? So I thought, well, can't they just, use FTP or something? Well, actually, that's not really practical, especially not for big data. Why is it? It's simply because any kind of traditional technology that you use to transport data, like FTP, for example. How many of you use FTP? Show of hands. Oh, quite a few. Okay, right. So you may know that when you use FTP, it has a drawback. It's based upon the TCP-based protocol. So it's a TCP-based protocol. And TCP degrades with distance. That's one of its major problems. So that means the longer the distance between you and the other person, or the sender or the receiver, if you like to look upon it that way, the worse the performance. And also it doesn't scale with bandwidth. So that means you could have a lot of bandwidth between you and the other person who needs to access the data, but it's not going to help you because TCP doesn't scale. So here's some examples. Okay, so say you're in London and you want to transfer some files over to Seattle. So there might be, as the previous speaker said, there might be a data scientist over in Seattle. You have an office there, and you need to get the data across to Seattle. Well, you have a 1 gigabit line over to Seattle, nice and fast, right? Okay, however, your two biggest enemies there in transporting data is the round-trip time and the packet loss rate. So the round-trip time is the amount of time it takes to send a packet from your office in London over to Seattle and get a response back again. And of course, on wide area networks, there's normally a bit of packet loss as well, even just as little as 0.001%. Now, what's the throughput you'll get there? One TCP, so if you do FTP, for example, so one FTP session will, over that line, get you 29 megabits per second. Did everyone sort of know that it was that low? And that means if you want to transfer 1 terabyte of data, that will take you 3.3 days with FTP. Yeah? So, not exactly fast. Okay. So, if you then then use Aspera to do the same thing, Aspera will allow you to use all your available bandwidth going from London over to Seattle. So, let's see if we can go back. Okay, so I'm having a bad PowerPoint day, but there you go. What that means is that you'll be able to actually transfer that big data set all the way from London to Seattle at line speed. Yeah, so instead of going with FTP at 29 megabits per second, you're actually going at line speed, i.e. roughly 999 megabits per second, which means, of course, means that your transfer will be a lot faster. Right, so now you say, okay, that's fantastic, but I want to transfer data within the UK. Yeah, I don't really care about transport, to the broad, but I just, have an office or a data center over in Glasgow, and I'm in London. So what kind of performance would you see there? Okay, so even at those distances, what you'll see is that you might have a round-trip time of 40 milliseconds. Could be less, could be maybe a bit more, it depends. A little bit of packet loss. And the result is, with traditional technologies like FTP, that will take you 50 gigabytes of data. Transferring that will take you about 3.1 hours. Whereas, of course, with Aspera, it will go at the line rate, so 299 megabits a second. And that means you can do 50 gigabytes in 23 minutes. A huge speed up, of course. So what we've solved is many things, but fundamentally the problem of actually getting data in and out of the cloud, but also, of course, over any kind of network and between any kind of distance. So Aspera allows you to run your transfers at maximum transfer speed, so utilize all your available bandwidth for your data transfers. And of course, at the same time, do this in a secure way, so you can encrypt the actual transport and you can encrypt the files themselves as well. And it's very low overhead. So that means you can run at very high speeds, but at the same time, the footprint required to do so on your servers is very low. Now, as you can see from that graph here, the previous graph you saw was the typical characteristics where you have some round trip time and packet loss for a TCP-based protocol. With Aspera, as you can see, you get the same performance, regardless of the round trip time, so regardless of the distance between the sender and the receiver, and also we're robust to packet loss. So a little bit more about the cloud. So we have work heavily with Amazon Web Services, and of course, one of the things they provide is their S3 object store for you to store your files in the cloud, or your kind of data in the cloud. And as you can see from these statistics, that currently now stands at 1.3 trillion objects, which sounds like an awful lot, and just shows the kind of adoption that you have with cloud-based services, and the actual upward trend with the increasing number of objects. Okay, so to transfer a file, what do you need to do, especially to the cloud, as this diagram depicts? Well, you have two bottlenecks. The first bottleneck is the actual transport from wherever you might be to the other side. So whether it's up to Glasgow or whether it's from here to I don't know, LA, for example, or Germany or France, or wherever it might be. And of course, the second bottleneck is if you transfer to the cloud, to actually get the data not just into the cloud, but also to get your data written to the object store. Now, most of these cloud, or I should say, what all cloud providers have in common is that they provide some sort of object store. Why do they do that? Well, it's simply because it provides essentially infinite storage space for all their customers. It's infinitely scalable, almost infinitely scalable. So that means your two issues then is getting data into the cloud. We solve that. You can transport data as quickly as possible using all available bandwidth. But then, of course, also Aspera allows you to then write to these object stores at a very high speed. So we have a gateway that sits on the server in the cloud that takes the incoming Aspera transfer and then transforms it into multiple HTTP sessions and writes it using the APIs of the object store at very high speeds. And the result is up to a gigabit per second on one instance, for example, in Amazon, all the way directly to the object store. And here's another slide, just some examples of the bottlenecks. So again, the first bottleneck would be the WAN, and the second bottleneck is actually the transfer, in this case, from the instance in the cloud provider, to the object store. How would you go about doing your transfers? Well, we provide a series of applications that allow you to do a transfer. So this would completely replace any kind of FTP-based solution you have today, for example. Just replace that and allow you to use, for example, simple web applications using a free browser plugin to transfer data, which means that the actual requirements for anyone wanting to do transfer are very low. All they need is a small browser plugin. Okay. And there are also a series of transfer service and also web applications which allow you to very easily exchange data. More about that later. So, just some use cases. You may have some data sitting in a data center. Maybe in this case, it's sitting in the US, and you want to share that out with some of your users. It's in many ways, it's not really just about the actual transport of the data, but it's also how you share that data out. So as the previous speaker was talking about data scientists who need to process data. Well, okay, that's fantastic, but the fundamental question is, even if you have the data scientist, how do you get the data to the data scientist for the processing? Or how do you get your data into your Hadoop cluster, for example? Yeah. So Sperry will solve that. And in this use case, what we have is an automated transfer of data to an Sperry server, where the file is presented in the web interface, and users can then log into that web interface, use the browser plugin to download it. Okay. And here's another use case. So I've talked about getting data in and out of the cloud, but of course another use case is what if you are using multiple cloud providers, or you want to migrate your data from one cloud provider to another. Well, we can do that as well. So in this use case, you have an automated transport of data from a node, so from an instance in US West in this case, going over to US East. So this is an automated transfer between Amazon two regions, and then of course a migration over to Windows Azure in this case. Okay, so the last use case, and this is where you have a lot of big data that you need to distribute to a person. We need to distribute it to groups. And this is taken from the life sciences industry, whereby the user would log on to one of our web applications, find the data that they need to send to someone in London in this case. And of course, there's no limitation on the size of the file here or the size of the file set. Yeah. This is, of course, another issue that you may have experienced with FTP. And it's not just slow, but it's not really built for transporting large files and large set of files. So in this case, you would then simply upload the file to the server. The recipient gets a link, clicks on the link, can then download the file at maximum speed. Okay, and then I think I'd like to finish off with this. So I've talked about some of the challenges, essentially distance and packet loss are the two major challenges in transporting your data. But of course, that's all fine. But then normally you would also want to automate your big data workflow, or big data flow, should I say. because of course it's all good having data sitting there in your data center, for example. Someone needs to get to it. Well, what we can also then do is help you actually automate that data flow. So automatically transport all those files from one location to another. And you could take that even further. You could not just automate those file transfers, but you could also automate the actual processing, i.e., you know, you could use a workflow orchestration platform like we have, which allows you to, for example, take some data, do some processing with the data, transport that data to a group of people, and once the data has been analyzed by that group of people, they send it back. The data gets validated. Maybe it's validate that it's in the right format. Maybe you want to do some virus checking on it, and then transport it back to the actual sender, who then needs to put that automatically back into their platforms for automated processing. Okay, if you want to know more about Aspera, you could go to cloud.asperasoft.com, where there's a lot of information available. Okay, and that was the Whirlwind Tour.